Moving forward, let us focus our discussion to one of the critical building blocks of your research proposal: the statement of the problem and hypothesis. These two components serve as the guiding light for the rest of your study. Without them, your research lacks direction and focus. Think of them as the compass of your research journey. If we get this right, the rest of your proposal will have a strong foundation. So let's start with a clear understanding of their role and how to formulate them properly. Let us start by understanding why the statement of the problem, or the SOP, is essential. First, it communicates the aim of your research. It answers the most basic but most important question: what is this study trying to find out? Your SOP serves as the heart of your research. It explicitly states what your study is trying to address. In essence, it answers the question, what is the issue you are investigating? This clarity is crucial so that your readers, including the panelists or future researchers, understand your focus right away. Second, it identifies a specific issue, concern, or gap in knowledge. For instance, if there is a recurring problem in infection control during clinical duties, your SOP should state this clearly. It is not enough to write about a general topic. A good SOP zooms in on a specific concern or gap. For example, don't just say you are studying infection control. Narrow it down to compliance to infection control protocols among Level 3 student nurses during their clinical duties. This shows that you've done your homework and that your study is needed. Third, it bridges your introduction and objectives. Once you have laid out the background of your study, the SOP transitions you into the specific goals. The SOP acts like a bridge between your background and your objectives. Once you have established your topic's relevance in your introduction, the SOP transitions the reader to the exact questions and goals you will be pursuing. And finally, everything that follows, your hypothesis, methods, tools, and even your interpretation, will stem from your statement of the problem. So you must write it with clarity and purpose. Every component that follows must be rooted in your SOP. That is why writing it well is not just an academic exercise. It lays the groundwork for your entire research paper. Let us talk about the general problem. This is essentially the big question your study wants to answer. You should present it in one clear, neutral sentence. It must encapsulate your research issue without bias or assumption. This means you are not assuming a new relationship or outcome just yet. You are simply stating what needs to be investigated. A good general problem is concise, direct, and serves as the starting point for breaking down specific questions. The general problem statement introduces the main research issue in just one sentence. This is your anchor. It's like saying, here is what my study is really all about. It must be clear, direct, and concise. No flowery language, no assumptions. You are simply stating the central problem that needs to be studied. Let us take a look at our example. For a given example, our general problem could be stated as: this study aims to identify the level of knowledge and compliance to infection control practices among Level 3 student nurses of College A during clinical duties. Notice the neutrality of the phrasing. There is no assumption whether the compliance is high or low, good or poor, and also there is no assumption about the level of knowledge. It is a simple identification of what the study wants to measure. The study population is clearly stated, Level 3 student nurses, and the context is given during clinical duties. This clarity helps readers immediately understand the scope of the study. Again, it is important to remember that the general problem must be neutrally framed. Avoid leading language like how poor is the compliance or why are students not complying. These presuppose a result before you have even done the study. A neutral framing keeps your study objective, which is vital, especially in evidence-based nursing research, where validity and reliability are paramount. A strong general problem must be neutrally stated. This neutrality is essential, especially for quantitative research where objectivity matters. Also, the language must fit your design, whether it is descriptive, correlational, experimental, and so on. Now, let us talk about the specific or the sub-problems. These sub-problems are the questions that break down your general problem into manageable parts. Think of them as the ingredient to your main research dish. Each specific problem focuses on a particular variable or component of the issue. Ideally, you should have 2 to 5 sub-questions. These are measurable, researchable, and will tie back to a part of your data collection tool. These sub-problems are written as questions, not as statements, so your readers can see exactly what you are investigating. Again, they should be researchable, measurable, and time-bound. For example, if your general problem is about knowledge and compliance to infection control, your specific problems might be: what is the level of knowledge of student nurses about infection control practices? What is the observed level of compliance during clinical duty? And to connect the dots, we ask, is there a significant relationship between knowledge and compliance? Each question targets a variable and guides the tool you will use to gather data. The last one even hints at the kind of statistical analysis you will be using. Each of these sub-problems should directly align with your parts or with the key parts of your research. First, every sub-problem corresponds to a specific variable in your study. Second, they should match sections in your research tool or instrument. For instance, a section measuring knowledge or a checklist for compliance. So if you have a question on knowledge, your survey or questionnaire must have items that assess infection control knowledge. Similarly, if you have a question about compliance, your tool should have a checklist or scale to measure observed compliance. This alignment ensures that your instrument is valid and that your data addresses your questions precisely. Lastly, each question will map onto a statistical test or descriptive analysis in your data plan. This structure ensures coherence and efficiency in your research. Writing effective specific problems is not just about asking any question. It is about asking the right kind of question in the right way. Always use simple and direct language. Avoid complicated sentence structures that can confuse your reader, or more importantly, yourself as the researcher. For example, instead of saying, "What are the influencing factors and the perception of the students regarding compliance?" This is too broad. Break that down into 2 separate, clearer questions. A good rule of thumb is to begin your question with words like what is, how, is there. These question formats are consistent with quantitative or mixed method research and signal a focus on measurable variables. For example, writing it this way: is there a significant difference? Or what is the level of knowledge? These starter phrases guide your writing toward clarity and precision. Avoid what we call double-barreled questions. These are questions that ask about two things at the same time, like what is the level of knowledge and attitude of students? These two variables, level of knowledge and attitude, in one question can be problematic during analysis. Instead, split this into two specific subproblems, one on knowledge and one on attitude. Make sure your specific problems align with your research title, your conceptual or your theoretical framework, and your hypothesis. If your title focuses on knowledge and compliance, your subproblems should not suddenly explore stress levels or time management. Stick to your variables. Finally, each subproblem must lead to an answer based on concrete evidence, data that you can collect, measure, and analyze. If a question cannot be answered through data gathering and analysis, it should not be part of your specific problem. Every question you write is a commitment, one that must be answered at the end of your research. Now, let us shift our focus to hypotheses. A hypothesis is your research prediction. It is your attempt to forecast what your study might reveal based on your review of literature, previous studies, theories, or even clinical observations. Think of it as your intellectual guess, but one that must be tested and validated through your data. Hypotheses are written only when your research is quantitative in nature, meaning it involves numbers, measurements, and statistical testing. Your writing of hypothesis is not required in purely qualitative studies because qualitative research does not aim to test relationships of variables, but to explore meanings and experiences. Also, hypotheses should be written when your study is correlational or comparative. When you are examining relationships between two or more variables or testing differences between groups. For example, if you are exploring whether knowledge influences compliance or whether specific profile such as age affects stress levels, you need a hypothesis to test those claims. Remember this crucial point. Hypotheses are not standalone elements. They must be based on your specific problems. If one of your sub-problems asks, is there a significant relationship between knowledge and compliance? Then that is the exact relationship your hypothesis should be testing. Never write a hypothesis that is not rooted in your SOP. It will confuse your readers and weaken your research structure. There are two main types of hypothesis you need to understand: the null hypothesis and the alternative hypothesis. Let us begin with the null hypothesis, symbolized as H naught or H0. This hypothesis assumes that there is no relationship or no effect between your variables. It serves as your default position and the one you aim to challenge through your research. For example, if you are studying knowledge and compliance, your null hypothesis would state, there is no significant relationship between knowledge on infection control and compliance to protocols. On the other hand, the alternative hypothesis, symbolized as HA or H1, suggests that there is a significant relationship between the variables. Using the same example, your alternative hypothesis would be, there is a significant relationship between knowledge on infection control and compliance. During your analysis, statistical tests are applied to determine if the evidence is strong enough to reject the null hypothesis. If it is, then you accept the alternative. This is the foundation of inferential statistics in quantitative research. It is also a process that adds credibility to your findings because it is based on objective data, not assumptions or opinions. So what makes a good hypothesis? Let us explore the qualities one by one. First, your hypothesis must be clear and specific. Avoid vague terms. You must clearly name the variables involved and the population you are studying. Instead of saying, there is a relationship between students and compliance, you must specify, there is a relationship between the knowledge of Level 3 student nurses and their compliance to infection control practices. It should be anchored in theory, literature, or observable trends. You are not guessing, you are predicting based on evidence. That is why your review of related literature is so important. It gives you the background to make reasonable, informed predictions. Your hypothesis must relate at least two variables. One variable is not enough. For example, you must state a predicted relationship like knowledge affects compliance. This relational structure is what allows you to apply statistical testing. The hypothesis must be testable through statistical means. You should be able to gather data, run statistical tests like Pearson R, chi-square, or t-test, and objectively evaluate whether the hypothesis is supported or not. Also, your hypothesis must be ethical and practical to test, especially in the field of nursing. You must not expose participants to harm or violate their rights just to prove a point. For instance, you can't test a hypothesis that assumes noncompliance by withholding information about infection control. Let us now look at an example to pull everything together. Suppose your subproblem asks whether knowledge is related to compliance. The hypothesis would look like this. Your null hypothesis would be stated like this. There is no significant relationship between knowledge and compliance to infection control practices among Level 3 student nurses. Then your alternative hypothesis will be stated this way. There is a significant relationship between knowledge and compliance to infection control practices among Level 3 student nurses. During your analysis, you will collect your data. Apply a statistical test like the Pearson correlation, and if the p-value is less than 0.05, for example, you reject the null and accept the alternative. This means your research has statistical support and your hypothesis has been proven to have merit within your study. Now that we understand how to construct good hypotheses, let us talk about how they must relate to your research subproblems. This is one of the most important principles in proposal writing, the alignment. Each subproblem must connect logically to a hypothesis. This is one of the most important points for coherence in your study. Each subproblem, especially the one that addresses relationships or differences, must have a corresponding hypothesis. You can think of the hypothesis as a proposed answer to the subproblem. For example, if your subproblem is there a significant relationship between knowledge and compliance? Then your hypothesis must directly test that relationship. Your hypothesis will then be there is no significant relationship or there is a significant relationship. This is what we mean by logical connection. If you ask a relational question in your SOP, your hypothesis must test that relationship using statistical analysis. What happens if they do not align? Let us say your subproblem is about infection control compliance, but your hypothesis suddenly tests the relationship between stress and sleep hours. That is incorrect. Your study lacks focus and structure. It creates confusion and it may even invalidate your results because your data will not answer the questions you originally posed. So always double check this. Does my hypothesis directly answer a specific problem? Does my hypothesis use the same variables and the same population mentioned in the specific problem? If I am asking about a relationship, am I testing that relationship? If the answer is yes to all three, then your study is aligned, and that is a strong foundation for any research project. This alignment also helps when designing your data collection tool, choosing the right statistical tests, and interpreting your findings. Everything builds on that structure. So never treat the SOP and hypothesis as isolated parts. They must flow logically, just like cause and effect. Here are key reminders that will help you maintain coherence, accuracy, and integrity across your research document. Consider this your quality control guidelines. From the very first page of your paper, everything must line up. If your title mentions knowledge and compliance, this should be the same variables discussed in your statement of the problem, broken down into specific problems, and tested in your hypothesis. Inconsistency across these sections weakens your study and confuses the reader. A well-aligned paper reflects a thoughtful and well-planned research design. Be consistent in the terms you use throughout your paper. If you refer to infection control practices in your SOP, do not switch to infection prevention measures in your hypothesis unless they are defined as the same. Consistency strengthens the clarity of your message. It also avoids confusion, especially when your paper is evaluated by different readers or panelists. Your hypothesis must match the structure of your conceptual framework and your research design. For instance, if your framework shows a pathway from knowledge to behavior or compliance, then your hypothesis should reflect that link. Also, your research design, whether descriptive, correlational, or comparative, dictates the type of hypothesis you write. You cannot test a relationship in a descriptive study. And you cannot write a directional hypothesis in a purely exploratory design. Everything must fit together seamlessly. Finally, do not skip the most important step: getting feedback. Your advisor and research panel have a trained eye for spotting inconsistencies, vague wordings, or logical gaps. Be open to their corrections. Submit your SOP and your hypothesis for critiquing. Be open to constructive feedback. This not only improves your manuscript, but also prepares you to defend your work with confidence and clarity. Here is a quick review on the statement of the problem and hypothesis. Your SOP sets the direction of your research. It starts with a clear general problem and then breaks down into specific answerable sub-questions. These guide your entire research flow, from your objectives to your data collection. Hypotheses are used in quantitative studies to test relationships or differences between variables. They are not guesses. They are carefully crafted predictions based on your specific problems, theories, or literature. They tell you exactly what to test and analyze. Everything must connect logically. Your title, problem statement, specific problems, hypothesis, and methodology should all speak the same language. When your research is aligned, it becomes clearer, more credible, and much easier to defend. A well-crafted SOP and well-aligned hypothesis are not just academic requirements. They are the foundation of strong, ethical, and evidence-based nursing research.